Okay, guys, welcome back to Mr. Morrow's Algebra class. Today we're going to move on to 2-4, solving equations with variables on both sides. Now, this is just another type of multi-step equation, okay? I would ask you guys that you just pay attention, especially for this first page, because you guys have most of this. There's going to be one thing different on this page, but we don't have much time, and I want to make sure that you understand this. So instead of trying to copy and rush and not understand anything, pay attention to the lesson now. I'm going to put this on a video, and of course you have the PDF notes so you can make sure you pay attention. Remember, please, that in a multi-step equation, the goal is to isolate the variables. Get the variable all by itself, okay? You want to solve for, of course, x over 1, a positive variable in the numerator, okay? That's what you want to solve for. Now, okay, sorry, I lost my train of thought there. Now remember, it's not always x that you're solving for. If it's z, that's fine. You want to solve for z over 1. If it's y, you want to solve for y over 1. You want to solve for the variable in the numerator and positive. Now, these procedures are all the same except number 1. Okay? Complete any and all distributive property to remove grouping symbols. We know that. But I added something now. This is the one thing that's added. Use properties of equality to clear decimals and fractions. What are we talking about? Well, if I've got 4.2, okay, if I got 4.2 plus 0.36x equals 1.72, I'm going to multiply both sides by 100 to clear out the decimals, correct? But since I multiplied 100 on both sides, did I change the value here or did I keep it equal? Think about it, guys. I multiplied 100 to this side and I multiplied 100 to that side. Did I keep both sides equal? Yes, because whatever I do to one side, I must do to the other. So that's what I mean by properties of equality to clear decimals and fractions. That's how you would clear decimals. And then how do you guys remember how to clear fractions? For example, if I got 3/5 plus 2/3 x equals 1, I don't know, tenths. Okay, you guys are saying reciprocal, and that's wrong. Reciprocal would be if I have a one-step equation like this. One-step equation. 2/3 is being multiplied to x. I got to cancel multiplication by division. When I divide both sides by a fraction, I multiply by the reciprocal. That's in a one-step equation. Now, that is not at all what I said to do to clear fractions. So again, we're going to ask, how do I clear the fractions, gentlemen? Sir, what about the least common denominator? You find it and then you multiply both sides of the equation by the least common denominator, which would be 30 over 1 in this particular case. Please remember, you do not multiply both sides by reciprocal, because the reciprocal of what, guys? There's 3 fractions here. That makes no sense. You multiply by the reciprocal to undo a one-step equation with a fraction in front of the x. We've done that already before. So that's the one main difference here, okay? You use properties of equality to clear decimals and fractions. Then it's all the same. Combine like terms on both sides of the equation. Move all the variables to one side. Undo addition and subtraction. And then undo multiplication and or division. So it's all the same. The only thing we added is once you are done with the distributive property, go ahead and get rid of decimals and fractions using properties of equality. Okay, so let's get to it. Today the skill that they really are going to focus in on or hone in on is when you have variables on opposite sides. Okay, this is very, very simple. To get one value that is positive from one side to another, what do? To get one value that is positive on one side of an equation, and I want to move it to the other side of the equation, how do we do that? You subtract that value to both sides. Good job, kid. And if I have a negative value on one side of the equation and I want to move it to the other side, I have to add that value to both sides. So in this particular case, I'm going to stick with the positive x's, me. So I got 5x and I got a 2x, right? Well, I'm going to go ahead and subtract 2x to both sides. And I got 3x plus 2 equals 14. Okay? That makes sense. That canceled. 5x minus 2x, 3x. Now I have a two-step equation. Minus 2 to both sides. 3x equals 12. Divided by 3 to both sides. X equals 4 is 100% correct. Okay? Now I am sorry, guys. We are going to have to hustle today. It's nothing new, though. Nothing difficult. We've done this. So I am going to go ahead and continue. You have to watch the video. Okay, I got 7x plus 2 equals 4x minus 10. Now I'm going to do it the other way just so you can see that you can have negative x's. I'm this time going to subtract 7x to both sides, which you absolutely, positively can do. I don't like to do it because I like to keep my x's positive, but it does not matter. That cancels. I got 2 equals negative 3x minus 10. Add 10 to both sides. 12 equals negative 3x. Divide by negative 3. X equals negative 4. It did not matter if I move over the 7 or the 4. You're still going to have the same answer, sir, I promise. Yes, sir. Thank you, sir. Yes, sir.
So, like on the homework, do a problem and we do the bigger x.
Yeah, no, it does not matter. What he's asking basically is, am I going to penalize you if you do it this way? If you, let's say, subtract 4x to both sides. No, you absolutely can do that. It's going to be negative 10, subtract 2 to both sides, and I promise you, if you did it correctly, you're going to get the same answer, I promise. So it does not matter if you want to keep the x's positive from the beginning or if you want to keep the x's negative. It does not matter which x you move to where, as long as you do it properly. Okay, if you have a positive value of x, you want to move it, you got to subtract that value to both sides. If you have a negative value of x, you want to move it to both sides, you got to add that value to both sides. Number 3, okay, we got distributive property first. So we distribute 10x minus 2 equals 3x plus 33. Subtract 3x to both sides. 7x minus 2 equals 33. Add 2 to both sides. 7x equals 35. Divide 7 to both sides. X equals 5. Nothing new here, really, gentlemen. Nothing really new here. Okay? Again, I apologize. I know this is a quick lesson today, but it's very thorough. You can watch it at home. It takes a graphic designer 1.5 hours to make one page of the website. Using a new software, the designer can complete each page in 1.25 hours. But it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? Basically, the designer spends 1.5 hours to make one page, right? He wants to know, and not H, come on, Moro, 1.5 P, where P is the number of pages, okay? He wants to know, when is that amount of time going to equal 1.25 hours per page plus the 8 hours that it's going to take me to actually learn it. This is what people do in the real world when they can save time. Oh, wow, I'm going to save 15 minutes every time I do this, but I got to learn the program, which is going to take me 8 hours. So I'm going to subtract 1.25 to both sides. And I'm going to have left over 0.25 equals, P equals 8 divided by 0.25. And P will equal 16. Or you could have done it the easier way. Get rid of the decimals by multiplying by 100, and you'd have 150p equals 125p plus 800. Subtract 125p to both sides. This is 25p equals 800 divided by 25. P equals 16 pages. Yes, you had a question, sir? You had a question, sir? Oh, okay. Go ahead, son. I don't have much time. Come again? I subtracted 1.25 to both sides, son. So then? This is 1.5 minus 1.25, son. But son, I already did that. I'm sorry, I did it in my head. I'm sorry. I mean, if you guys don't know how to do decimals, you need to focus on that and revisit that. Now, let me show you real quick. Real quick, bear with me. Bear with me. This is 10x plus 12 equals 10x plus 12. You subtract 10x to both sides, you get 12 equals 12. Is that a true statement? When it's a true statement, what are the solutions? All real solutions. If it's a false statement, what would it be? No solution. Have a great day. God bless you all. Bye-bye. So, for example, here you can go ahead and go. I'm just going to finish this up for your video. You got 2x plus 7 equals distribute. Negative 3 plus 2x. Subtract 2x to both sides. Does 7 equal negative 3? No. That is false. And when it's false, it's going to be no solution. Thanks again. Have a great day. God bless you all. Bye-bye.